Good morning, we are Group 22 and today we will be talking about the material used in food packaging. Food packaging is essential for protecting food from contamination by creating a barrier against bacteria, viruses, and debris. It regulates exposure to air, moisture, and light, preserving flavors, nutrients, and texture. Effective packaging extends shelf life, keeping food fresh and nutritious beyond its production date. In this presentation, we will be mainly focusing on these four main properties: optical properties, sustainability, moisture, and oxidation resistance. While this discussion focuses on these specific properties, it is important to note that other factors also influence the selection of food packaging, such as cost effectiveness, mechanical properties, thermal stability, and feasibility. The four main food packaging materials we are focusing on are paper, metal, glass, and plastic.
Paper has several distinct properties, spanning across opticality, sustainability, moisture resistance, and oxidation resistance. Paper packaging is primarily opaque, preventing consumers from previewing food contents inside the packaging. Usage of paper is highly advantageous owing to its biodegradable properties, which make it highly sustainable. In terms of moisture and oxidation resistance, coatings like wax or polyethylene are required to improve its ability to protect food from moisture and grease, as well as avoiding absorbing moisture from certain greasy foods. Lastly, with weak oxygen barrier properties, additional coatings are needed to prevent oxidation in sensitive foods.
Moving on to metals, there are three different types of metal commonly used for food packagings, which are aluminum cans, tin-coated steels, and electrolytic chromium-coated steels. The properties of metal consist of its excellent barrier properties and opaqueness, ability to withstand extreme conditions and temperature, ductile and malleable to shape the cans. However, as it is heavy, transportation is expensive and costly. Metals have excellent barrier to light, oxygen, and moisture, contributing to its high score in moisture and oxidation resistance. However, metal corrodes and interacts with food items, thus a coating is required. Due to these excellent barrier properties, it prevents degradation of food quality, preserving taste, freshness, prevents spoilage and microbial growth, contributing to a longer shelf life. Metals are highly recyclable, making them a more sustainable choice by reducing waste and pollution. While metals are recyclable, production process is energy intensive, resulting in higher costs. As compared to other materials, it has low optical due to its opaqueness.
Glass packaging, typically soda-lime glass, is valued for its optical and preservation qualities. Its transparency allows consumers to see the product, enhancing trust and visual appeal. It is also fully recyclable without quality loss. However, its production has shown to be energy intensive. Glass is chemically inert, non-porous, and provides a strong barrier against air and moisture, all of which maintain the quality, taste, and aroma of the food inside. Now, despite having very high scores in the four criteria, it is important to note its physical disadvantages of being brittle and relatively dense.
Packaging is one of the most common materials used in the food industry because it's durable, versatile, and cost-effective. It helps protect food by creating an airtight barrier that preserves freshness and extends shelf life, especially for perishable products. Plastics used in food packaging are classified into 7 categories, each identified by a recycling number from 1 to 7. Some types are safer and more suitable for food contact than others. Among these, PET, HDPE, LDPE, and PP are the most commonly used in food packaging. PET is typically used for beverage bottles, HDPE is used for milk jugs, LDPE is used in flexible packaging like bread bags or cling wraps, and PP is used for yogurt cups and microwavable safe containers. This variety shows how plastics can be engineered to suit specific packaging needs, whether it's flexibility, strength, or resistance to moisture and oxygen. Now, let's compare how these 4 plastics perform in key properties. Firstly, for PET, it stands out for its clarity and oxidation resistance, which help keep food fresh and visible, making it ideal for beverage bottles and clear containers. Its rigidity also provides strong impact protection. HDPE has excellent moisture resistance and strong chemical stability, perfect for milk and juice bottles. However, it's less transparent and has lower oxidation resistance than PET. LDPE is known for its flexibility and moisture barrier, making it great for bags and wraps, though it is weaker in clarity and oxygen protection. Finally, PP offers a good balance across properties and is used for yogurt cups and microwavable containers thanks to its heat resistance. Although none of these plastics are biodegradable, their durability and functionality makes them essential in food packaging. After averaging the results of PET, HDPE, LDPE, and PP, plastics as a whole scored a total of 13 stars across the 4 key properties. Lastly, by compiling the scores, glass has the highest score out of all the materials. However, as mentioned earlier, several other factors must also be considered. For example, glass is very brittle for food packaging. And in the end, each packaging material has its own strengths and weaknesses, and the best choice depends on the specific requirements of the food product.